Hi, my dear students. Welcome to India's biggest online platform, ME Educational Institutions. Today, we are going to start a wonderful chapter, ray optics. In this session, we can talk about some introduction to geometrical optics. In this session, first we can have a look on the some fundamental definitions used in geometrical optics. After that, applications of laws of reflection. Finally, we can solve some problems related to laws of reflection. Let's start the session. Geometrical optics is the study of light in which dimensions of objects much higher than the wavelength of light. Here we are having different objects we will be discussing in upcoming classes. Here mirror, lenses and prism. Size of these objects much higher than the wavelength of light in this particular geometrical optics. In geometrical optics, the propagation of light is represented by a ray. The propagation of light, see here, the propagation of light is represented by a ray. The arrow represents direction of propagation. In this particular ray, you will be having an arrow. Arrow represents direction of propagation. Just to see here, this is the ray. Here, this particular ray coming from the light and incidenting on the eye. Observer. Okay na? So here this is the ray. Arrow represents direction of propagation. Generally the propagation of light represented by a ray. Okay, so here one more thing I want to tell you, light is nothing but it's a part of electromagnetic spectrum which helps us to see the objects. In general, light is used to see the objects. Actually, light is the part of electromagnetic spectrum. One more thing I want to tell you, light always travels in a straight line. Path of light is called a ray. Bundle of rays is called a beam. Understood now? So these all are some fundamental definitions in this particular geometrical optics. Some fundamentals of geometrical optics. Here one important point here is dimensions of objects much higher than the wavelength of light. After that, the propagation of light is represented by a ray. Ray, in this particular ray, you will be having arrow. Arrow represents direction of propagation. And light is a part of electromagnetic spectrum which helps us to see the objects. Understood now? So it always travels in a straight line and path of light is called a ray. Bundle of lights is called a beam. Bundle of lights is called a beam. These all are some fundamental definitions of this, but some introduction to geometrical optics. Now we can have a look on the different objects. Obviously, in geometrical optics, the size of the objects are much higher than the wavelength of light. What are the different objects we need to study? Just see here, we are having two types of objects. One is luminous objects and non-luminous objects. What is meant by luminous objects? See here, the objects that emit light. The objects which emit light. See here, which emit light, or the objects which produce the light. Which produce the light by themselves are known as luminous objects. For example, we are having sun. Sun, it produces the light. Okay, so this particular bulb, it emits light. A bulb can't produce the light, it emits light. Bulb and then candle, these all are emitting light. Understood now? Light is a form of energy. It is emitted by the luminous objects, or else it can produce the light. Okay, so in both the case, we can call those objects as luminous objects. I repeat, luminous objects are the objects which emit light or produce the light themselves are known as luminous objects. You can see the sun, bulb, and candle. So it emits the light. That is why you are calling sun, bulb, and the candle or luminous objects. For example, now we need to have a look on the non-luminous objects. Of course, non-luminous objects are the objects which can't emit the light. Okay, so it can't produce the light. See here, objects that don't produce their own light are known as non-luminous objects. For example, chair, bench, table, and wall. These three, or else whatever the object which is not producing, which is not emitting the light, those objects are called as non-luminous objects. So these are the two different objects we need to study in geometrical optics. So I repeat, here we are having two types of objects. One will be, here we are having two types of objects. One is luminous objects and non-luminous objects. In case of luminous objects, it emits light or produce the light. In case of non-luminous objects, which can't emit or produce the light themselves, whenever a light incident on non-luminous objects from the source is nothing but luminous objects. When light incident on the non-luminous object, you are able to see these non-luminous objects. Understood now? These objects can't produce or emit the light themselves. In this manner, we can classify the objects as two types, luminous and non-luminous objects. Now, a wonderful topic, reflection. It is one of the important topic in ray optics. Understood? Entire geometrical optics, reflection is one of the important topic. We need to discuss in detail about reflection. After that, properties of light, then laws of reflection. First, what is reflection? See here, if the light rays strikes the boundary of two media, then the part of light gets absorbed and part of light will be reflected into the same medium. Here, some amount of light incident on the body, in that some fraction of amount of light will be absorbed by the body. Some fraction of amount of light will be reflected from the body. Here, reflection, main important part of the reflection here is light will be incidenting from one medium. It is reflected to the same medium. Here, medium will be same in case of reflection. In case of refraction, medium will be different. So we can discuss one by one in detail. This is the source of light and observer and object. From the source, light will be incidenting. This is the incidenting. Here, I can say that this is the incident ray. This would be incident ray. Light is incident ray. Some amount of light is incidenting on the object. After that, it is reflected ray. I can say that this would be reflected ray. Here, some amount of light incidenting on the object from the source. I think this is medium 1. I can say that this would be medium 1. It is reflected to the same medium. Medium is same here. Okay. In case of reflection, medium will be same. Reflected to the same medium. Here one thing I want to tell you, source, this is the source. From the source, incident ray is coming and incidenting on the object. Here some amount of light will be reflected and it is reaching the observer. That is why you are able to see these objects. Here the chair is what? Non-luminous object. This chair is not emitting the light or not producing the light. But how are you able to see this object? Because of this particular process. From the source, light is incidenting on the non-luminous object, then it is reflected from the surface of non-luminous object and it is reaching the observer. Okay, see here, since the non-luminous objects like chair, wall don't produce their own light, these objects can be seen if the light from the luminous objects falls on them, reflects to the eye and creates the perception of vision. You are able to see these non-luminous objects because of this particular reflection of light. This reflected ray reaching your eye, then retina, this particular retina present inside the eye will feel the vision, perception of vision. You can see that objects. This particular process will take place in fraction of seconds. That is why you are able to see the objects, mainly because of this particular process. Understood now? From the source, light is coming. This is the incident ray, incidenting on the chair, reflected from the surface, reflected to the same medium. Same medium is very, very important. Reflection is the phenomena. In this medium will be same. Now we can discuss in detail about reflection. In some more discussion about reflection here. Very simple. This is the source. So main source of seeing objects is sun. From the sun, light is coming and incidenting on the object, and the reflection, reflected ray reaching your eye. By that you are able to see the objects. Here this is the object. From the source is a sun. From the source, incident ray is coming, incidenting on the object and reflected from the object, and the reflected ray reaching the observer eye. Okay, so in this manner, this is the incident ray. I can say that this would be incident ray. This would be incident ray, reflected ray. This would be reflected ray. So you are able to see that, you are able to feel that object, you are able to see that object, you will get perception of vision. See this, we can see any objects, it may be luminous object or non-luminous object, because of the following reasons. One will be the main reason is reflection. Due to reflection of the light, and if the radiation from the luminous heated object lies in the visible region, whatever the radiations commit, every body emits radiation. If those radiation within the visible region, you are able to see the objects. That part we can discuss in the chapter radiation. Okay, so for time being, we need to talk about reflection. Okay, so because of the reflection, incident ray incidenting on the object, reflected ray reaching the observer, by that you are able to see the objects. This is the, here medium will be same. Okay, so here reflected ray and incident ray coming from the source. This is the medium one, and the reflected ray is reflected. This particular reflected ray is coming into the medium, same medium. Here medium will be same. We can discuss properties of the light. So this is also one of the important topic here, properties of the light. When the light ray, here we need to discuss about reflection and refraction. What is the reflection and refraction? So we can discuss clear-cut difference between reflection and refraction. See here, when the light ray falls on the interface of two mediums, there will be two possibilities. We already discussed this part. When light ray incidenting on the surface, there are two possibilities. Some amount of incident ray is reflected from the surface, some amount of incident ray absorbed by the surface. Once the incident ray, some amount of light will be reflected to the same medium. Some amount of light will be absorbed. That absorption process, that is nothing but refraction. Here, in case of refraction, mediums will be different. In case of reflection, that is reflected ray is reflected into the, that is passes into the same medium. Medium will be same in case of reflection. Medium is not same in case of refraction. See here, the ray reflects back to the same medium. The ray transmit into the other medium. We can discuss in detail about this reflection and refraction. This is the source of light, and this is the interface of two mediums. This is the interface of two mediums. Here medium 1 and medium 2. Here medium 1 and medium 2. Just observe. Medium 1, medium 2. Light ray incidenting, this is the source. Okay, here light ray is coming from the source, incidenting on the surface. Here some amount of light will be reflected from the surface. Some amount of light is transmitted into the other medium. Okay na? So here this particular, here the ray, this particular incident ray, reflected ray is back to the same medium. Okay na? Incident ray and reflected ray both are in the same medium. Understood na? But this refracted ray is transmitted into the other medium. Incident ray coming from the medium 1 and reflected ray is back to the same medium. Refracted ray is transmits into the other medium. In case of refracted ray, medium will be different. Understood na? So it is transmits into the other medium. Understood? So here other medium, that is one of the important topic. Because of that, velocity of the light and wavelength of the refracted light will be different. Understood na? Here velocity of incident ray, velocity of reflected ray, both will be same. Frequency is same for all the rays, but wavelength case, wavelength here, wavelength of incident ray, wavelength of reflected ray, both will be same because of same medium. Coming to refraction, velocity of the refracted light and wavelength of the refracted light is not same as the wavelength and velocity of the incident ray. Understood na? So here V dash and lambda dash, here V and lambda. So you can observe here, in case of reflected ray, velocity is not changing, wavelength is not changing, and frequency, velocity, frequency and wavelength of the reflected ray is not changing. It is same as the incident ray. But in case of refracted ray, velocity of refracted ray and wavelength of the refracted ray, both are changing. Both are not same as the velocity and wavelength of the incident ray. You can clearly see this here. Now we can discuss about in detail about this. What is meant by, we already seen this here. Incident ray coming from the source, medium 1 and medium 2. Incident ray coming from the source, incidenting on the surface and reflected back to the same medium, transmits into the other medium. Incident ray, reflected ray, refracted ray, and wavelength, frequency and velocity, frequency and wavelength, velocity, frequency and wavelength, and both are same in this case. Here velocity and wavelength both are changing. So coming to the reflection clear-cut definition here, the phenomena in which the incident ray reflects back to the same medium of the origin of light is known as reflection. The ray is known as reflected ray. Here the phenomena in which incident ray reflects back to the same medium of origin of the light. Origin of the light is nothing but, what is the origin? So it is coming from the source. Of course, this is the origin. Origin of the light present in the medium 1. It reflects back to the same medium. Understood now? So that is the basic phenomena of this particular light is nothing but reflection. Reflection is the phenomenon in which incident ray reflects back to the same medium of origin of light is known as reflection. The ray is known as reflected ray. And here this is the incident ray and the reflected ray. Here I can say that incident ray, this would be incident ray, this would be reflected ray, Okay, so here in case of, we already discussed this part, in case of reflection, velocity, frequency and wavelength of the light remains same as the incident ray. Okay, now, so here whatever the wavelength and velocity, frequency, wavelength of incident ray, velocity, frequency and wavelength of reflected ray exactly same. Understood now? So these are not changing in case of reflection. Understood? So now we can talk about refraction. What is meant by refraction? The phenomena in which the incident ray transmits through the interface of two mediums and travels into the other medium is known as refraction, and the ray is known as refracted ray. We already discussed this part. Here the ray transmit into the other medium. We already discussed this, medium 1 and medium 2. Some amount of light is incidenting on the surface, some amount of light will be reflected from the surface, some amount of light will be refracted, transmitted into the other medium. That phenomena is nothing but refraction. Here incident ray, reflected ray and refracted ray, wavelength, frequency and velocity here. So we already discussed this part. Here this part is what? This is the medium 1 and it is transmits into the other medium. Here this is nothing but incident ray, the origin of the light, incident ray, the origin of the light present in the medium 1, but it transmits into the other medium. That phenomena is nothing but refraction. This is refracted ray. This would be refracted ray. We already discussed this. Refraction is the phenomena in which change in velocity of the light occurs due to change in medium. Hence, only frequency of the light remains same after refraction. Frequency is not changing in case of reflection and refraction. In case of refraction, velocity of the light is changing and wavelength of the refracted ray is changing. Understood now? So here this is the velocity, here V dash. Velocity of the refracted ray is not same as the velocity of incident ray. Wavelength of refracted ray is not same as the wavelength of incident ray. This is all about some funda related to refraction. Understood now? So this is the some funda related. Main thing is medium. Understood? I repeat here. I repeat this. The phenomena in which incident ray transmit through the this incident ray transmit through the interface of two mediums, transmits into the other medium, travels into the other medium. Understood now? Here transmit through the, this is the interface, transmit through the interface of the two mediums. Understood now? So that is the refraction. Incident ray coming from the medium 1 and refracted ray transmits or travels into the other medium. That is the basic difference between reflection and refraction. This is the some funda related to reflection and refraction. Now, terminology used in reflection. See here, this is the angle of incidence, angle of reflection, both are important. These two are one of the popularly used terms in this particular reflection chapter. Understood? So here angle of incidence, this is the mirror, this is incident ray here, and reflected back to the same medium, this is reflected ray, incident ray, reflected ray. Now we need to draw the normal to the plane surface, mirror or plane surface, that is fine. This plane surface or polished surface, okay na, both are fine. Here we need to draw normal to the surface, plane surface. What is the normal to the plane surface? We need to draw the perpendicular or normal to that. Now, angle made by the incident ray with normal is nothing but angle of incidence. Now, angle of reflection is nothing but angle made by the reflected ray with the normal is nothing but angle of reflection. Understood now? The angle that the incident ray makes with the normal is known as angle of incidence, and it is denoted with I. The angle made by the reflected ray with the normal is nothing but angle of reflection. It is denoted with R. Understood now? Angle of incidence, angle of reflection. Okay, so both are very, very important. So I repeat this. This would be plane surface. Here, I repeat this. This is the plane surface. Incident ray incidenting on the plane surface, reflected back to the same medium. This is reflected ray, incident ray, reflected ray. Now we need to draw normal to the plane surface. This is the normal to the plane surface. Angle made by the incident ray with normal, angle of incidence. Angle made by the reflected ray with normal is nothing but angle of reflection. These two definitions are very, very important. Angle of incidence I, angle of reflection R. Now we can have a look on the one of the important topic, laws of reflection. Here we already know this part. Just observe angle of incidence, angle of reflection. Here I and R. What is laws of reflection? So angle of incidence is equal to angle of reflection. is called law of reflection. So the angle of incidence I equal to angle of reflection R. I equal to R. Here I equal to, I can say that I equal to R. Angle I equal to angle R is nothing but laws of reflection. Law of reflection. Angle I equal to angle R. Now, incident ray, reflected ray and normal at point of incidence all are present in the same plane. Understood now? So here incident ray, this is incident ray, reflected ray and normal at point of incidence all are lie in the same plane. This is one of the law of reflection. Laws of reflection are valid for reflecting surfaces of any shape. So these three are laws of reflection. Understood now? One of important law here is angle of incidence equal to angle of reflection, and these three rays present on the same plane. Thank you. We can meet in the next class. Thank you.